Hello everyone. Today I'll be talking about water potential and chemical potential, part 2, osmotic relations of plant cell. The cells have an osmolarity and it is surrounded by a thin layer of primordial cuticle which consists of tonoplast, thin protoplasmic layer and the cell membrane. This layer as a whole performs द सेमी परमेबल फंक्शन इन प्लांट सेल्स। प्लांट सेल के ऊपर एक पतली मेम्ब्रेन प्रेजेंट होती है विच इज़ प्रोटोप्लाज्मिक इन नेचर, प्रोटोप्लाज्मिक लेयर होता है एंड ये एक सेमी परमेबल मेम्ब्रेन की तरह फंक्शन करता है। द सेल सेप एग्जिबिट्स ओनली that fraction of its total osmotic pressure that is due to the solutes to which the membrane is impervious. It is the fraction of total osmotic pressure of the cell shape that is known as tonicity. When a solution has got the same osmotic pressure as that of the cell shape, it is known as the isotonic solution. A hypotonic solution has relatively low concentration as compared to the cell shape and water osmosis into the vacuole. A hypertonic solution has a higher concentration of solute particles than the cell shape. So, the protoplasmic shrinkage influenced by hypertonic solution is known as plasmolysis and the cell is said to be plasmolysed. जब हाइपरटोनिक सोल्यूशन की वजह से प्रोटोप्लाज्म श्रिंक हो जाता है, सेल से सारा सेल शेप यू कैन से लिक्विड वाटर जो है वो बाहर निकल कर आ जाता है, उस प्रोसेस को हम प्लाज्मोलाइसिस कहते हैं और सेल को प्लाज्मोलाइज्ड सेल कहा जाता है। इफ सच अ plasmolysed cell is transferred to pure water again or a hypotonic solution, water will diffuse into the vacuole. अगर इस प्लाज्मोलाइज्ड सेल को हम दोबारा से प्योर वाटर के अंदर रखेंगे तो वापस हाइपोटोनिक सोल्यूशन के अंदर रखेंगे या फिर तो पानी वापस से उसके अंदर एंटर करना शुरू कर जाएगा और सेल अपनी नेचुरल कंडीशन में जो भी उसका नेचुरल स्टेट था उसके अंदर आ जाएगी। द प्रोटोप्लाज्म ग्रेजुअली बिकम टर्जिड एंड रिकवर्स इट्स नॉर्मल अपीयरेंस। दिस फिनोमेना इज नोन एज डीप्लाज्मोलाइसिस और इसका प्लाज्मोलाइसिस का ऑपोजिट फिनोमेना हो गया एक तरह से ये, तो इसको हम डीप्लाज्मोलाइसिस और डीप्लाज्मोलाइज्ड सेल कहेंगे। The stage at which the protoplasm just starts to shrink and come out from the wall is called as incipient plasmolysis। और वो वाला स्टेज जहाँ पर प्रोटोप्लाज्म श्रिंक होना बस शुरू ही हुआ है और वाटर जो है वो सेल वॉल से सेल से बाहर निकलना शुरू हुआ है, just beginning of plasmolysis, we call it incipient plasmolysis. Hence, you can say that a plasmolysed cell remain alive and may be deplasmolysed by immersion in water, although prolonged plasmolysis is irreversible and result in death। बहुत लंबे समय तक अगर आपने सेल को प्लाज्मोलाइज कंडीशन में रख दिया है तो माइट बी सेल आपका डेड हो जाएगा और मे बी सेल हमेशा के लिए परमानेंटली अपने फंक्शंस को लॉस कर दे। When the osmotic potential of the cell shape is more negative than that of external solution in which the tissue is immersed, the water will enter the vacuole and the volume of protoplasm will increase, which exerts a pressure on the wall, and this pressure is called turgor pressure, TP। We called it TP। जब पानी अंदर एंटर कर रहा है सेल के अंदर, लगातार प्रोटोप्लास्ट के अंदर पानी एंटर कर रहा है तो उस वजह से सेल ज़्यादा स्वेलअप हो जाएगी, सेल वॉल के ऊपर एक प्रेशर डेवलप होगा और उसी को अपन टर्गर प्रेशर कहते हैं। द ऑस्मोटिक प्रेशर, टर्गर प्रेशर एंड द सक्शन प्रेशर, we called it diffusion pressure deficit, DPD, collectively known as osmotic quantities of the cell। तो osmotic quantities or you can say osmotic property of the cell is depends upon three types of pressure. One is the osmotic pressure. Osmotic pressure develops turgor pressure or diffusion pressure deficit और इन तीनों को हम एक साथ बोलेंगे, these are what? Osmotic quantities of a cell. Now, the wall is a non-living rigid structure. It is not a living structure that is made up of lipids and protein. So it restricts the degree of volume change by imposing a hydrostatic pressure on the vacuolar sac. This is known as wall pressure. वॉल जो है वो अपने आप को रिस्ट्रिक्ट करेगी, एक लेवल तक अपना वॉल्यूम इंक्रीज करेगी और एक हाइड्रोस्टैटिक प्रेशर उसके ऊपर लगेगा वैक्यूलर सेप की वजह से, और उस प्रेशर को अपन क्या बोलते हैं? वॉल प्रेशर, WP. द टर्गर प्रेशर विच इज डिनोटेड बाय P, ऑफन कॉल्ड प्रेशर पोटेंशियल, इसको हम प्रेशर पोटेंशियल भी कह सकते हैं, एंड वी कैन डिनोटेड बाय psi P, is included as a component of the water potential. That means the potential of cell, psi cell or dPd. Thus you can say that psi cell, potential of a cell is equals to potential of turgor pressure plus potential of solutes. S is here potential of solutes. Potential of psi cell equals to psi P plus psi S. Now, psi cell is also denoted by P minus psi, and here as you can see pi equals to minus sin S. When such a cell is immersed in pure water, water will move into the cell, and until and unless psi P equal in magnitude to sin S, and the total water potential of a cell is become 0. So the fully turgid condition at which water absorption stops, formula is what? Psi cell equals to 0, where psi P plus psi S is equal. Or you can say it like this कि माइनस साइन एस इज इक्वल्स टू साइन पी, वो उसके नेगेटिव हो जाएगा वैल्यू जब हम साइन एस को इक्वल्स के इधर लेके आएंगे, एंड दिस मीन आप यहाँ ऊपर देख सकते हैं कि साइन एस की वैल्यू जो है दैट इज इक्वल्स टू पाई, तो यू कैन से पाई इक्वल्स टू पी. तो पाई इज व्हाट? द osmotic pressure is equals to actually the turgor pressure. When the same cell is placed into a solution of low pi s, water will come out of the cell. This is the opposite phenomena. जब हमने कम solution उसके अंदर रखा साइन एस के अंदर, तो पानी बाहर निकलना शुरू हो जाएगा. At the point when membrane ceases to exert pressure against the cell wall, साइन P becomes 0. कोई प्रेशर नहीं है मेम्ब्रेन के ऊपर, जब पानी निकल गया एक्स्ट्रा तो वो 0 हो जाएगा, एंड साइन एस इज देन इक्वल्स टू द साइन सेल. तो उस कंडीशन में साइन एस जो है दैट इज इक्वल्स टू साइन सेल, एंड दिस पॉइंट इज एक्चुअली द इनसिफिशिएंट प्लाज्मोलाइसिस. साइन एस इक्वल्स टू 0, साइन सेल इक्वल्स टू साइन एस, और साइन सेल इक्वल्स टू पाई. सो द मूवमेंट ऑफ वाटर is a response of psi cell, not just to psi s. At equilibrium, net flux of water is 0. The above interrelationship of the components of water potential refers to an ideal plant cell. Sin P is usually positive or 0 in an individual cell, but it becomes negative in transpiring xylem tissue when the water column inside the plants आर सब्जेक्टेड टू नेगेटिव प्रेशर और टेंशन. जब लगातार ट्रांसपिरेशन होता रहेगा, वाटर लॉस होता रहेगा जाइलम टिश्यू के अंदर, तो वहाँ पर नेगेटिव प्रेशर एक डेवलप होता रहेगा, एक टेंशन डेवलप होती रहेगी, ताकि प्लांट्स जो है मैक्सिमम अमाउंट में वाटर रूट से एब्जॉर्ब कर सके. सो साई एस इज ऑलवेज नेगेटिव और 0. यू कैन से टोटल वाटर पोटेंशियल साई सेल इज जनरली नेगेटिव और 0, बी पॉजिटिव इन सीव एलिमेंट्स. सीव एलिमेंट्स के अंदर पॉजिटिव होगा, अदरवाइज इट इज नेगेटिव और 0. नाउ मेट्रिक पोटेंशियल. The plant cell is a complex system and contains molecule of colloidal protein and other hydrophilic surfaces such as cell wall as well as simple solute ions and molecules. There is no pure water in plant cell. That is always a combination of so many things, or a colloidal solution you can say. So the cell wall are composed of a mesh of cellulose, microfibrils, pectic substances, proteins, and several other constituents with a large number of hydroxyl and carboxyl group which adhere water by hydrogen bonding. Hydrogen bonding के through उसको adhere करेंगे. Water is also held by surface टेंशन इन इंटरफिब्रिलर स्पेसेस, जो सरफेस के बीच में जो प्रोटीन एंड लिपिड्स के बीच में जो स्पेसेस होता है, इंटरफिब्रिलर स्पेस, उसके अंदर वाटर इजीली होल्ड हो जाता है. Removal of water from this metric cell wall requires considerable amount of force due to the attraction between the water molecule and the matrix. वाटर मॉलिक्यूल और जो मैट्रिक्स सेल वॉल के अंदर प्रोटीन्स एंड लिपिड्स होते हैं, उनके बीच में एक इंटरेक्शन हो जाता है. तो वाटर मॉलिक्यूल को इस इंटरफिब्रिलर स्पेस से रिमूव करने के लिए आपको कुछ फोर्स, कुछ एनर्जी लगाना पड़ेगा. एंड दिस इज नोन एज मेट्रिक और imbibitional force and usually termed as metric potential, or you can denote it as psi m. So the metric potential is a measure at atmospheric pressure of the tendency to absorb additional water molecule. Extra water molecule को absorb करने की tendency होती है atmosphere से, and it is expressed in unit of water potential. The magnitude of water potential is lowered by this metric potential. Now, determination of water potential. The working principle is that the water potential of a cell or a tissue is the same as that of liquid with which the tissue is in equilibrium, where psi m equals to 0. It means that the psi is equal in all parts of the system. Thus, at equilibrium state, psi can be determined for any plant part. Applying this principle, water potential of a tissue is determined by the following method. The water potential of an unknown tissue sample may be determined by finding a solution in which the tissue neither gains or nor loses volume or weight, indicating no gain or loss in water where P is 0. The tissue sample is placed in a range of solution of different molar concentration of a non-permeating harmless osmoticum such as sucrose, sorbitol, mannitol and PEG. After equilibration, changes in tissue volumes are measured when plotted against the molar concentration of the external solution. The intercept on abscissa x-axis gives a value corresponding to the cell sep concentration, which is C, at atmospheric pressure. When turgor pressure P equals to 0, psi W equals to pi, and here the pi is calculated by the equation, that is CRT, and this method is known as tissue volume method. Here you can see in this diagram that on an x-axis we are taking the concentration of the solution, sucrose solution, which is in increasing order, and on y-axis this is denotes the percentage of loss or gain in weight or volume. There is a point, you can see एक center के अंदर point है जहाँ पर line cross हो रही है, where there is no change in weight and volume, and here the psi p equals to 0. cell sep concentration जो है इतना है कि इस कॉन्सेंट्रेशन के ऊपर ना तो टिश्यू के अंदर पानी जा रहा है, ना पानी आ रहा है, ना लॉस है ना गेन है. तो दिस इज द इक्विलिब्रियम पॉइंट, यू कैन से. Second one, other method where psi w of a tissue sample can be measured by measuring the changes in weight of a tissue rather than the changes in the volume at equilibrium. The method is essentially the same as the tissue volume method, but here we are only measuring the weight rather than the volume, and this is also known as gravimetric method. Then we have another alternative approach to measure the changes of the concentration of the external test solution instead of changes in tissue. So it is better approach than measuring tissue volume or weight. This is known as Shardakov method because it is discovered by V.A. Shardakov. In this method, two graded series of solution of proper osmoticum, you can take sucrose, mannitol or PEG, it's your choice, are taken in duplicate sets of test tube. Tissue samples are placed in one test tube of each duplicate and this series in the test series. The second tube of which set is colored slightly by dissolving methylene blue, which does not change the osmotic potential significantly, and these are the control series. After 15 to 30 minute incubation, the tissues are removed and a droplet of equivalent control solution is introduced into the test solution. As you can see here, we have taken one is the test solution, another one is the control of different concentration, सेकेंड में हमने ड्रॉप डाला सोल्यूशन का, एंड यू कैन सी इन फ्यू ट्यूब्स, सेकेंड ट्यूब्स, drops are floating upward direction. In second tubes, drops are going down, drops are sinking. If the color droplet rises, it means that the solution has become more dense, indicating that the tissue has absorbed water. In this case, the water potential of a tissue is more negative, that is lower than the original solution. Conversely, if the droplet sinks, it means that the test solution is lighter than the original solution, an indication of that water has come out from the tissue and diluted the solution. In this case, the water potential of a solution is lower, negative than that of the tissue. If the droplet diffuses uniformly in the test solution without rising or sinking, then no changes in the concentration has occurred. This point is called actually the null point, where there is no change in concentration of solutes or solution inside the cell, in which the water potential of a tissue and the solutions are equal, both are in equal concentration at the equal concentration level. At this stage, Turgor pressure P is equals to 0. Therefore, you can say that sin W is equals to pi, and which is equals to CRT. And the concentration changes in the external solution may also be directly determined by determining the changes in refractive index of the external solution by a refractometer. You can assess the values by the refractometer, and this is known as refractometer method, and the former is known as falling drop method. Another sophisticated method to determine the water potential of a tissue is the vapor pressure method. This is done by thermocouple, psychometer, or a similar device. In this method, the water vapor pressure of the air in equilibrium with the tissue in an enclosed chamber may be determined directly. A temperature depression is caused due to evaporation of the small water droplets on the wet bulb of a thermocouple. This temperature depression is proportional to the vapor pressure in the chamber, and it induces the changes in electrical conductivity. Now, the water potential psi W of a leafy twig or a shoot may be measured by pressure bomb technique. The pressure required to force out the xylem sap from the cut end is equivalent to the psi W and existing in the tissue before cutting. This value is equal to magnitude but opposite in sign to the tension in intact xylem. Now the next method is in which water potential may also be determined indirectly by measuring the relative water content RWC of a particular tissue, and the formula of RWC is equals to weight of initial fresh weight of the tissue, then the dry weight of the tissue upon turgid weight of the tissue minus dry weight of the tissue into 100. Thank you. This is all about water potential part 2.